All right, in this video we're going to talk about scatter plots and trend lines. Exciting stuff. First, we're going to talk about scatter plots themselves and what this bivariate data is. So go ahead and get this into your notes. First, scatter plots. Right? Scatter plots are a graphical display. They're a picture of bivariate data. Right? Remember, this whole unit is all about data, quantitative and categorical. Now that we're talking about scatter plots, we're talking about quantitative data. And remember that quantitative data has units, okay? So when we're talking about scatter plots, we're talking about bivariate data, that's quantitative, and by bivariate we mean two variables. So down here we have height and weight. Those are both quantitative data. Height could be measured in inches, centimeters, what have you. Weight measured in pounds, ounces, grams, but they have units. So now we have the data coupled along with its scatter plot. So again, this is the graphical display of our two categories. Height with its units in inches, weight with its units in pounds. So weight is going to be on our y-axis and height is on our x-axis. And all of these dots right here represent these players. So let's see if we could find Kareem Abdul-Jabbar. He has a height of 86. So I follow along until I get to the 86, and I go up, and there's only one dot here. That's this one right here. And when I follow it over here, it's right under 270 pounds. When I look, yeah, it's 266. So that seems to be a reasonable location for that point. So you should be able to identify anybody. See if you can find Wilt Chamberlain. Press pause. Okay, and as you can see, I've circled Wilt in the blue ink right here. Hopefully that's what you chose. So this is what a scatter plot of that data looks like. Just to be really brief here, in order to draw the scatter plot, what I would do is I would look at my weights and my heights, and I would try to come up with number lines that made my world easier. They went down the number line, even though these go by twos, there's a little tick mark in between, so they went 72, 73, 74. So this goes in unit order. And as you look over here, the smallest we had to deal with was 73, and the largest we had to deal with was 86. So they just made it so you only had what you needed to deal with. Technically, the authors should have broken the scale by putting a little squiggly mark here and here, and then starting to 72 at this point. But I'm not gonna nitpick the scatter plot. So the next piece of vocabulary that we want to conquer here is trend lines. Okay, what are trend lines? Down in the pictures below here, you see some trend lines that are attempted to have been fit to the data that we were just looking at in the scatter plot. So these scatter plots are just duplicates of the original scatter plot we were just looking at. But first, what is a trend line? Here are a couple of reasonable definitions that I've cut and pasted for you. Press pause now and get these into your notes. Okay, so a trend line is a line on the graph showing the general direction that a group of points seems to be heading. Also, it is a statistical technique to aid in the interpretation of the data. So, let's take a look. Several students draw trend lines to fit the data. And so when we take a look at what's going on, we see that right here, this student chooses to grab a couple of points and actually draw the line right through it. But it says, explain why neither of these data fit the data well. Well, or neither of these lines fit the data well. And the reason that is this first line undershoots, or sort of undermines the points right there. So it doesn't really do a good job at maintaining the balance of the whole picture. Student 2 sort of does the opposite thing. It sort of overshoots all of these data. So when you're using this to aid in interpretation of data, both of these lines are really not going to do a good job at guessing other values based off of the values that you have. Let's move on. Students 3 and 4 now, and number 2 on your handout, students 3 and 4 also do their best. So this student obviously is way off the mark. This line right here doesn't fit the data at all. I mean, the first two students at least had the general direction of it a little bit better. This last student right here, I think this is the check plus version that I would like to use. This student has a good line that will aid in the interpretation of the data. Out of the 4 students, student 4 I think has the most reasonable trend line because some of the data is just above the trend line, some of it's just below, and actually it even goes through one of the points, but that's not necessarily the case that we need. We don't have to touch any of the points. We just want a good overall approximate interpretation of the general direction. The next portion of the game here is going to get a little bit more complicated. So let's take a look at the instructions. Find the coordinates of 2 points on the trend line you chose from question 2 and use them to find the slope of that line. So let's choose a couple of points. I chose Magic Johnson and Michael Jordan, and the reason being, looking, and this point is clearly right on the trend line, and this one was pretty close. So I follow this down to 83, and I notice that the 83 value is Magic Johnson. Follow this one down to the 78-inch height mark, and that happened to be Michael Jordan. They were just coincidentally next to each other. So now what I want you to do is use these 2 points to find the slope of the line. You should know how to do that. And then we're going to interpret that slope. So press pause now and calculate the slope. All right, now see if you can follow along. First thing I did, if you'll notice, is I took my 2 points, I put them in coordinate form, x being inches, so 83 inches, 255 pounds, 78 inches, 215 pounds. I labeled them up, substituted them in my slope formula. I ended up with -40 over -5, which gave me an 8. Just because it was a nice integer answer doesn't mean it always has to be. And we're always going to just crunch this down to some number over 1. Then keep in mind that slope is changing y over changing x, so the units is very critical now in interpreting data, and this is where it gets tough. Y units are pounds, x units are inches. So when I look at this, this is 8 pounds, right? 8 pounds per inch, or 8 pounds per inch. So what I'm really saying is, as a player increases 1 inch in height, they're going to increase, or they should, the model sort of predicts that they're going to increase 8 pounds. You're going to gain 8 pounds per every 1 inch. This is tough stuff. Let's keep going. Now the next part of this asks us to find the equation of the line that you chose in question 2. Okay, so we're looking at a slope given of 8. One of the points we chose was 83, 255. I like to use the point slope formula. So y minus y sub 1 equals m times x minus x sub 1. You finish this out. Get this into y equals mx plus b form. Press pause now. Okay, and this is what I get. Down here, I get y equals 8x minus 409, or the weight is an estimation of 8 times the person's height minus 409. That should give us a ballpark estimate of somebody's weight. What I do to check my arithmetic is I take the other point that I had used and I substitute the height of 78 into my height piece right here. I multiplied 8 times 78, subtracted 409, I get 215, which is what it's supposed to be. So I feel pretty comfortable that this is good to go. Now we can move on and answer some further questions. So here we have 2 questions. One asks us to predict weight based off of an NBA player whose height is 71 inches, and the second one asks us to predict weight based off of a player whose height is 82 inches. So what do? You just use your equation, right? And I've gotten a little shorthanded here. Weight equals 8 times height minus 409. So you take your height of 71 inches, place it in there, crunch out a weight number. So your weight is equal to here. And then for D, your estimated weight is equal to here, based off of your 82 inches. You substitute those in, and then bring those answers into class. All right, we're almost there. Now, taking a look at this picture here, it says that these scatter plots show the relationship between temperature and ice cream sales. The same scatter plot, right? These are the same exact scatter plots with different trend lines. Which one do you think is the best one? Do you think A? Hopefully you're looking at A and you say, no, that's overshooting the data. Take a moment, look at all 4, press pause, and think about it. Now hopefully after thinking, you chose graph C. So graph C is the best one because it does the best overall job at giving us a reasonable prediction. Now, what does the slope of the line tell us about the relationship of the two variables? And we're looking for something sort of generic here. So you're going to want to press pause and copy the sentence into your notes, but generically what we're saying is that the data, and data is plural, datum, D-A-T-U-M, is singular. The data suggests that as the temperature increases, the volume in ice cream sales also increases. As temperature goes up, so does the sales of ice cream. Seems like a basic statement to say, but that's all we want to do. We want to interpret that data. We want to give the person who's looking at the graph an interpretation of what they're looking at using context of the question, temperature, and ice cream sales. The next thing they want us to know is, does this relationship make sense in real-world context? And yes, to a certain extent, yes, but only to a certain temperature. So I'm going to say here, yes, but only to a reasonable degree. And I'm not trying to make a pun with respect to temperature. All I'm saying is that there comes a point to where the temperature is going to max out, and eventually so will ice cream sales. In business, we would call that a saturation point. This last problem is going to be on you to bring into class as well. It says, what was the approximate Fahrenheit temperature the day the ice cream sales were the greatest? Okay? Formula relating this was introduced in Unit 2, or you're savvy, refer to a book, goodness, an actual textbook, hard copy book, or go online. So we're going to go somewhere. I'm going to identify this as that highest point because this is the greatest sales, and we'll come down there, and let's just agree that this is 24 degrees Celsius. All right? Till next time, take care.